So we're over at the milling machine and I have my setup done. On the milling machine I have the base plate standing vertical on the machine table and I clamped it against a big box parallel. It's screwed on with two hold down bolts, and I will show you in a second the back side of the setup. Here you can see the box parallel that I'm using. This is a big cast iron box parallel, and I clamped it to the table with two screws, and I clamped the base of the angle plate against it with two bolts and two strap clamps to give me some support. Now we can center on the existing bore carefully because there is a keyway slot in it, and bore it open to the next even number. Right now I'm in the process of boring the bearing hole open to 29 millimeters, and it's always fun when I get opportunity to break out my Wohlhopper UPA-1 boring head. This is this is superior German engineering. It's a masterpiece. It's a Morse Taper 2 boring head. You don't need tools to adjust the diameter, and it has a facing feature, so you can run it and hold this ring while it's running and you will create a face. You can face a flat surface square to the bore you just machined. That's quite a handy feature from time to time, and it's really a neat piece. They show up on eBay from time to time and they are expensive, but great tool to have. So let's take a look at the adjustment. This is the clamping screw. This one locks the slide and the adjusting ring up here at the same time. It pushes directly against the clamping gib, and there is a ball and a 45-degree chamfered push pin which pushes up against the ring here. And we have this nicely engraved dial up here which shows 1/100th of a millimeter in diameter per division. So I want to go on 0.3 millimeters. So 0.1, 0.2, 0.3. Then we lock it. And get the spindle back in gear. I disengaged it so I can turn it freely. Okay. There we go. I like to retract the tool with the spindle standing still, and in this case it's very easy because I can turn the tool so it sits in the key slot in here, and I can retract it without scratching the bore. Otherwise I would have to live with the scratch of the tool in my bore, or I have to retract the tool slightly. Now we can move out the table a bit. We can take a measurement. That's nice when you have a DRO. You can move the table in and out as much as you want. You can always get back to zero. Now we take our 2-point internal mic and take a measurement. Yep, we are 1/100th of a millimeter undersize. I can live with that because we're turning the shaft that will go through this bore anyway by our own, and we can make that a hair undersized so it goes in nice and tight. Yeah, this is looking good. 28.99. That's very good. And just in case you were wondering, I'm using one of the boring bars I made in a video earlier this year with the small high-speed steel bit, and they work very well. They short and very stiff, so gives a good surface finish in the bore. Okay, took me some time to figure out how to indicate the lower bore in line with the upper bore. But in the end effect is a pretty simple setup. I have the X direction is set by my box parallel, and I didn't change it when I flipped around the part to bore the upper hole, so I don't have to indicate the X direction. I only have to indicate the Y direction because there is no stop. And I have my indicator reaching around this this lock here, and now I can indicate around like this and get almost the full 180 degrees that I need to indicate the lower bore. And I read 0 to 0 from side to side. So that's my setup to indicate the lower bore. Now I can get the indicator out. Oops. And get back with the boring head and bore out the other side. Okay, we're over at the surface plate, and I have both of the holes bored open. Now I'm checking if the line through these two bores is parallel to the surface plate. And I have my dial indicator and the surface gauge over here, and I found the low spot in this bore somewhere. That's a bit fiddly. And it's 0 over here. I can pull back. I can push this over. And I can look on this side. And it's 0 over here too, within a few thousandths of a millimeter. So that's perfectly fine. I'm quite happy how this came out. And it should also be in line with the front and back. I will check that too. Let's stand this up on the surface plate and do the same. Turn around so you can see at least something. Okay, this is 0. We can pull this over, get this around, and check it on this side too. That's okay, and we are 1/100th of a millimeter off on this side. So the bore is 1/100th of a millimeter tilted. I think I can live with that, and I even could correct this error by scraping the long sides of the base. But I think I will not bother with that. That's good enough. Okay, I think I got the base so far finished, so we can proceed on with the tilting top of it. I got all important surfaces scraped, and I bored out the pivot so it's straight and true to the base. Now we can proceed on with the tilting top, and I have it just propped up here on the table because I'm thinking through the order of operations we're going to do on this piece. And I think the first step will be to clean up those T-slots because they are machined but not really very nice. And then we might continue to scrape the top surface and the side surface square and true to each other. And then we will, like the base, stand it up like this, bore it, flip it around, and bore the other side. And as you can see, I have propped the table up here, and I have my straight edge here. And when I set the straight edge up here, you can see light coming through in the center of the table. And that's of course because the table is not flat. And I have my feeler gauge here. This is a 5/100 of a millimeter leaf, and this does not fit between the straight edge and my tabletop, so it's less than 5/100 of a millimeter hollow. That means we don't have to machine the surface, we can just scrape it. 3/100 of a millimeter is a piece of cake to scrape off with the power scraper. Okay, I'm cleaning up these slots to a width of 11 millimeters. I already did the center one, and the two other ones are to follow. Running a 4-flute high-speed steel end mill coated at 580 RPM with power feed, of course. You might guess what I'm doing right now, judging by the tool I have clamped up in the spindle. That's right, we're truing up the T-slots with a T-slot cutter. I already did these two, and when I crank the table out of the way, yeah, very much travel left, going in the other direction, you can see the difference. This one is all wonky, and those two can only see this one right now. This is nice, crisp, and machined on all surfaces. Especially the bottom, the inner bottoms or the top surface of the T-slot. This surface here, that's where the T-slot nut rides on and exerts pressure onto the table. And that has to be machined properly. Otherwise, yeah, you might crush some material, or your clamping setup might give in if your T-nut does rock or slip slightly. All bad things can happen. So it's nice to have these T-slots machined square. Running the T-slot cutter at 580 RPM. Okay, I finished the T-slots and I did something else. If you remember, I machined the T-slots to 11 millimeters. And when that 11 millimeters is an odd size for T-slots. I have hardware for 10 and 12 millimeter T-slots, so I changed my mind and I opened them up to 12 millimeters. So they accept my normal T-slot nut and also my precision T-slots for aligning stuff. I have a pair of them in 12 millimeters. And they are a very tight fit in the slot, as they should be. Okay, I think we're done on the milling machine, and when I tear down the setup you will be able to see how I had this piece clamped up. So let's take off the clamps. So when I take off the casting, you can see that I had 4 screw jacks under there with a pin on top that has a spherical top, and I used that to tram in the part level to the machine and square to the travel of the machine. I tweaked the individual screw jacks under the part until it was all in line, and I have this nice machined T-slot plate without the need to machine the back of it. I can leave this raw casting, and you can see the imprint from the 4 spherical pins into the paint of the casting. Tramming the part in is a bit fiddly, and 3 screw jacks would be easier, but would be not as stable, not as rigid as with the 4. Okay, let's check the tabletop for flatness. We already did this kinda with the straight edge before, but now we will see the dirty truth of the casting. This doesn't feel very flat at all. Yep, that's not very flat. We have heavy bearing here, and over here, but nothing in the center. Okay, I scraped the top surface flat. I didn't show that again because you saw it already on the bottom surface of the base. And on this angle I really like the pattern of just checkerboard scraping when you alternate by 90 degrees and leave small scrape marks. Looks kinda neat, and for some reason I like that more than a flaked half-moon surface where somebody just went over with a half-moon scraper with the half-moon Biax shaper, where it just point and shoot your half-moons onto the surface. I don't like that at all. This is dead flat. You see only light in the scraping valleys, not on the overall length of the straight edge. So I'm quite happy with this surface. Now we're going to the surface plate and check the upper and lower surface if they are parallel to our T-slots, because the T-slots are our real reference. We will set it up on the surface plate and check this. Before we go to the surface plate, we're going to stone this surface, which will sit on the surface plate. And I have my stones, so I'm doing quite a lot of stoning right now in a shallow plastic bin with some WD-40 sitting. And that keeps the stones wet and washes out the debris and keeps them nice and sharp. Only problem is that it's a real mess. But the cast iron clogs up the stones really fast if you don't use some form of lubrication. You can also use petroleum or I think mineral spirits would also work, but WD-40 is what everybody has in their shop, so I'm using that. Okay, cleaning the surface plate, and I'm not using a surface plate cleaner, I'm using window cleaner. in my mind that's pretty much the same stuff, just cheaper. And it leaves a nice clean surface where, for example, the surface gauge slides very nicely. Now we set up our part on the surface plate. If you want to really get down and catch every bit of dust on your surface plate, use your bare hand. You set your part onto the surface plate and you slide it. And then you will hear and feel if it's properly sitting on the surface plate or if there is a speckle of dust between the part and the surface plate. And I'm just using the height gauge as a indicator holder right now, because it's nice and convenient to adjust the height with the hand wheel. So we go into the T-slot and we zero it on the inside of the T-slot here. You should be able to see this now. We have 0 over here and now we go to the left. And we have about half of a hundredth of a millimeter, that's 5/1000 of a millimeter difference from this side to this side, so that's okay. Zero. Half a hundredth of a millimeter, so 5/1000 of a millimeter left to right. So we're just going to make the lower surface flat. We scrape them just flat. We don't have to do any correction on the orientation of the surface. So this surface down here is parallel to this, and to this. That double line is the symbol for parallel. We have to check the upper surface too. 0. Ooh, okay. We have 0 over here and plus 0.03 of a millimeter over here. So this upper surface needs some tweaking. We have to bring it down to be parallel with the T-slots and the lower surface. But that's not too hard, and 0.03 of a millimeter is not that much. Okay, I scraped the reference surface flat and to somewhat of an even pattern. You can see the bluing here is kinda even. I used a bit much blue, but you still get the idea. The diamond high spot blue I am using shows very badly in camera. It's very faint. I would have to use the Dicam high spot blue, but I don't have a lot of that stuff, so I don't mess around with it on camera. And if we wipe off the blue, you can see that I have a pretty nice pattern, scraping pattern here. And when we take a look along it and use a precision square, we go down onto the scraped reference surface, you can see there is no light gap at all. So the surface is also square to this surface, and it's parallel to my T-slots. So that's where we start. Now we can flip the part around and scrape the other side parallel to this side. Okay, I scraped the bottom side which was already parallel to the T-slots, and now we're going for the upper side, which is high 300 millimeter on this side. So we have to tilt this whole surface to the left, from my stance left, over here, 300 of a millimeter down, and we don't want to change this side very much. So it will get clear when we do the scraping. I will start to scrape the whole surface lightly, then I come back and take a heavy pass about the half to 2/3 of the length of the surface, 1 or 2 passes, and that will slowly tilt the surface in the correct direction. Then we will go over to the surface plate, take a measurement, and then we will correct again until we have a dead parallel surface without a surface grinder. So power scraper is set to a stroke of about 15 millimeter, and we're good to go. Okay, I scraped over the whole surface once, lightly, so when I use the high spot blue, I have something on the surface to catch the color. Otherwise this would be, you smear the color. Now we will remove some material from here to about here. Let's take 2 passes with the power scraper. Okay, I don't want to take too much in the first pass because there is always danger of going too far. I would take our stone, and I'm wetting the stone with some WD-40 so it stays clean from the grinding, from the cast iron dust. Now I'm going over to the surface plate and I will glue the surface. I'm not going to film this, you saw this quite a lot of time. Be right back. And we're back. You can see that we're only hitting on the outer edges, which is quite good. This will go very fast to get it even. I will do 1 pass just to clean it up and give it a bit better bearing, and then we will take a measurement. Here we go. Let's take our stone, clean it off with some alcohol. I like to use some degreasing, something to remove the grease or oil, like alcohol, because otherwise when you get it onto your high spot blue on the surface plate, everything smears up and you have to clean the whole surface plate and start all over. That sucks. Before we check it for flatness, we'll check if we are already parallel to the bottom surface. And I'm changing back to the height, to the surface gauge, because right now the space on the surface plate is quite crammed up. Back here I have some layout, some high spot blue. Here in front I have some layout blue, and here I have a clean spot where I can do measuring. And the surface here is of course not flat, so we can't directly measure with the dull test indicator onto it. We need something to bridge the gaps between the high and low spots. So a gauge block will do fine. Just take a gauge block onto the surface, make sure it's clean. Slide it in place, and get our dull test indicator on top of it. And zero it out. So here we are now with 0. Now we can pull it over, pull the gauge block over and bring it in again. And as you can see, we are 1/100th of a millimeter high over here. Yeah, that's really looking very good. We make a little bow right in this area. From here to here it rises about 1/100th of a millimeter. Everything else here is 0. And this is +1. 1/100th of a millimeter. Yeah. I think we will see this when we do the bluing of the surface. We should get some bearing points here, very less here, and some over here. Reapply the paint or respread it and take a rub. And that's about what I was thinking. We have some spots here and some over here, nothing in the middle. So let's go back to a bench and do a few passes with the scraper. Third pass. Fifth pass. Okay, sixth pass, and as you can see the pattern is now pretty even. I will do the sixth pass, scraping pass, and then I will redo the measurement because everything has evened out, and then we will see if we still have to correct for the parallelism between the two surfaces. Okay, same setup as before with the gauge block to bridge the scraping marks. I zeroed it out, and when we now move over, we bring in our gauge block, we have about 0.005 of a millimeter left to write. That's good. That's kind of okay. And just for fun, we can break out the 0.002 of a millimeter dial test indicator, just to see how much it really is. Zero it. We get 0 here. We get 0 here. Settled in. Now we can move over. Bring in our okay, that's 0.004 of a millimeter. Two lines on the dial. So that's quite good. I don't have to be ashamed of that. That's 0, and over here we are plus 0.004 of a millimeter. That's quite okay. And that's really what I like about scraping. You can get super accurate results, and I could it even get better than this if I invested more time. You can refine it to be 0, 0 everywhere, but it takes time, and the more precise you want to be, the more you have to be very aware of burrs for cleanliness on the surface plate and the accuracy of the measuring devices you're using. This is a 0.002 per division MAR dial test indicator. This is the most sensitive and precise measuring tool I have in the shop. I have a 0.001 of a millimeter to digital indicator, but for some reason that thing doesn't seem to be as precise as a dial instrument. I prefer this one. It's way more sensitive. Okay, we are over at the milling machine because when I checked the faces of the T-slot table, I realized that it's very square in this direction. It's almost dead nuts on, but when we take a square and we look over the surface in that direction, we are off about 0.2 of a millimeter, 0.2 millimeters, and that's a bit much. I'm not in the mood to scrape that out. I'm using the milling machine for that. And I already did the first side, came out very good. And I'm just clamping the piece against the box parallel. And very convenient, this part has T-slots, so I can use T-nuts to hold it. Just using 2 of them with some clamps on the other end to give me some clamping surface against the box parallel, and I fiddle everything through the box parallel. Yeah, need to take off these clamps to get them through, otherwise I will pull out my hairs. Like this, and I put the clamp behind it. Now we can take a light skim pass over the surface of the face. Let's go down 0.2 millimeters or 0.25. I'm using the Z-axis because I have a digital readout on there. Running at 95 RPM and a slow feed. Okay, I took a very light skim pass over the surface.